Right, law of cosines is kind of like law of sines, where we're going to use it to solve for all the missing pieces of a triangle that is not a right triangle. But it would be used for when we have different information than when we have law of sines. As just a quick reminder about law of sines, when you use law of sines, you had to have an angle and the opposite side to use law of sines. You had to have an angle and its opposite side to use law of sines, plus one other piece of information, whatever that may be. You had to have 3 pieces of information, but there had to be an angle and the opposite side. That was for law of sines. That's how you could cross multiply itself. Law of cosines, what you need to have is you need to have, well, there's 2 different situations, but one case would be that you had all 3 sides. So you didn't know any of the angles. But if you have all 3 sides and you don't know any of the angles, you can find all of the angles by using law of cosines. There are 6 different versions of this same formula. There are 6 different versions of this same formula. If you're going to use the standard form, you would use this when you're solving for a missing side. And you would use the alternative form if you are solving for a missing angle. That's when you would use different forms. You can use the standard form for every single case, but what they've done is they've already set it equal to the angle, so you just have to plug stuff in on the one side rather than put them in both sides and solve. They just made it super easy on you. All of these are the exact same. They're just solved for different sides. So the first one, if you're solving for side A, you would use the first one. And notice that you have to know angle A to solve for side A. For the second one, if you were solving for side B, you would have to know angle B. For the third one, if you were solving for side C, you would have to know angle C. Where are side C and angle C located in a triangle? They're opposite. So if you're solving for a side, you have to know the opposite angle. Now this is very important that I'm trying to explain through these, because you're going to get an example that might not have an A and a B and a C. And how would you know which formula to use if there's not an A, B, and a C, if there was an X, Y, and a Z? You know, the main part is that these are the opposite. And then lowercase b and lowercase c would be the other sides. Over here, the opposite angle and side are located in these places. Then everything else in the formula are all the other sides. All right, so let's see how this formula works. With example 1, find 3 angles. Find all 3 angles. So let's start by finding angle A. So to find angle A, we're going to do cosine angle A equals, and we take the other 2 sides that are not A and square them. The other 2 sides that are not A. So 14 squared and 19 squared. We subtract off the side that is A squared. It's kind of Pythagorean theorem related. Kind of. I mean, that's where it came from a long time ago, whoever made this up. Then we divide it by 2 times B times C, so 2 times the other 2 sides that are not A. Now I'm explaining the formula because you might have to use it without knowing what A, B, and C are. You might have X, Y, and Z. Now, what are we trying to actually solve for? We're trying to find angle A. So how do I find angle? So what I'm going to type into my calculator will be inverse cosine of that big, long fraction. So type it in your calculator. Make sure that you are getting the correct measurement of angle A.
Frisbee open. I don't remember getting it.
Well, you come up with that software, and I bet you make a lot of money.
It's probably not that hard to do.
Well, do it.
Two.
That sounds about right.
Yeah, that's
3.07.
It's kind of dark. I do not know why it's so dark. Oh, there it goes. So you should get approximately 22.08 degrees. If you're not getting that on your calculator, let me come help you. Just a reminder that accuracy is important. And when we do find other answers, we're going to use not rounded answers to plug in, but we're going to use the full exact answer from before. So if you have those newer calculators, it should be really easy for you. If you have the older ones, you might need some assistance doing it. What was it, 0.8?
Sure.
Yeah. I'm not looking at it, you guys. Trusting you. All right, so how do we find angle B?
We're going to do this again.
Yeah. It wasn't bad. It just took a moment to type it in your calculator. But we'll do cosine of B. When we set it up, almost everything in there is the other two sides, with the exception of what you subtract. That's the B squared. So everything else is going to be the other two sides. 14 squared plus 8 squared. Minus 19 squared. Is that, do I have the correct B? What's B? Yeah. Okay, just making sure. And then we divide that by 2 times 14 times 8. And then to actually find it, you have to do inverse cosine of that. Mm-hmm.
Do the 180 thing to find the last one.
Well, we have 2 ways to find the last one. Oops, I was just trying to show you that I was doing on my calculator. You should get 116.80
If
degrees.
you want to be able to do 180 to find the last one, I think you do.
I'll do it on the calculator. I'll do it.
Right, but like, what do you press to hit to make sure you get both of those exactly?
Let me just write this answer down, and I'll show you.
Now you can use answer once.
Yes. So to get C, it depends on your calculator for that. You have the new one. Good. So I'll show you. To get angle C, you can either do the same thing again with C. I mean, it's really not that much work. You could do the same thing again, or you could just take out 180 degrees and subtract off that last answer. ANS. Answer, ANS. And then you'd have to subtract off the other one. But we're talking accuracy. So I'm going to show you how to do it if you have the newer calculators. If you have the older calculators, you're going to have to like type in like more than 2 decimals. So on the newer calculators, what you can do is 180. I could subtract my last answer, which is the 116. But then I can use my, I do subtraction, I'm going to use my arrow, and I'm going to go up to this one. And when I'm on it and I hit enter, it like brings it down for me. So instead of using answer, you could actually bring it down on a lot of the newer calculators. And I don't even mean the color ones. I think it does it on the older new calculators too. But you can try that to see if that works for you. Then you'll have to retype it. Otherwise, you'll have to retype in that decimal. But it should be on your screen still. So we should get 41.12. if you're ready to go on. Let's go on. Look at the next one. We're going to find the remaining sides of side and the angles. So can we use law of sines?
No, because we don't
The
have.
only angle we don't have the opposite side. So we cannot use law of sines. But we can use law of cosines. The law of cosines, the formula, this has A, B, and C, so it should be easy to just copy the formula. But I'm going to talk like we're not using the formula. I'm just going to talk through like where everything is in the formula. It starts with the side you don't know, squared. And it kind of starts out looking like the Pythagorean theorem. You do A squared equals B squared plus C squared. Those are the other two sides you don't know. Or that you do know, sorry. Then we always do minus 2 times, and you do B and C again, sine of the angle that we do know that is opposite that side we're trying to find. Yeah, cosine, I'm sorry. You know, I was just talking about law of sines and that kind of, my brain was stuck on it. Yeah, I'm full of them. So when I actually plug all this stuff in, I'm going to have A squared, which I don't know, equals 15 squared times 10 squared minus 2 times 15 times 10 cosine of 115.
I don't think those are both. Is it plus or multiple?
Okay, so when you do all that, before we even type it in our calculator, let's just think about what our next step is going to be. You're going to want to square root. So I might as well make that part of me writing down my work right now and do less on my calculator. Just open a square root, type everything underneath it, and hit enter.
It's like the full length of the thing.
Yeah.
21.
Did you get it? So am I going to use this rounded answer to find new answers? No, I'm going to use the exact answer. So I'm going to keep it handy on my calculator. We have found side A. 21.26 is the approximate answer for side A, centimeters. But that is not exact. So when I do my next step, I'm going to use my answer button or, you know, arrow up and bring the other value down. I'm not going to use 21.6 or 26. I had other people using that and getting it wrong because they were using a rounded version. So do we now have an opposite angle and an opposite side?
Yes.
So if I wanted to, I could now use law of sines. So I'm going to show you using law of sines. If you want to use law of cosines, you can do that too. But if you wanted to, you could use law of sines because we have these. We would do sine, or we would do 21.26, but I'm not actually going to use that number. I'm going to use the answer over sine of angle A, which is 115. What are we trying to solve for? Angle B. I'm going to find B and C, so we can find angle B. So side for B is 15 over sine of B. And we cross multiply. Solve for B. Yeah, you'll do that too. And since we're trying to find B, you're going to use inverse of sine of that fraction, and I used answer, I didn't use 21.26. All right, I'm slow. 15, sine 115. For answer. There we go. So 39.76. So if you did not get 0.76, you didn't get the exact answer. You got an approximate. Well, this is still an approximate, but you got a less accurate approximate if you didn't use 0.76. Why is that there?
Take it out.
Yeah.
I did
Look to
something
your
weird.
right, look,
Yeah.
look
Okay.
to your right.
Just wondering. Oh, this one came up too. All right, so we got what was it now? 39? And then how do we find angle C?
180 minus.
Right, we just do, right. $25.24. The formula itself looks more complicated, but I think you have to have so much information to use law of cosines that you have to have three sides or two sides of an angle that you just plug it in at that point. All right, so we have, this is just a real life example, but there's nothing tricky about this one. We need to find how far is the pitcher's mound from first base. So you look here, what are we trying to actually find in this picture?
Angle or H.
We're trying to find H. Ooh, there's no A, B's, and C's. So what you're trying to find, the side, that's like what you set it equal to. And if it's a side, it would be squared when you plug it into the formula. So then the next part of the formula would be the other two sides. 43 squared plus 60 squared. The formula is always minus 2 times the other two sides, 43 and 60. Cosine of the angle opposite of what you're trying to find, 45. You could probably do that one without even using technology. Well,
No thanks.
43 squared and 60 squared.
well, yeah, you probably want to. But you could because we know cosine 45. Are we going to? No. So when you type it in with the square root, save yourself a step. And I'm sure that's something you always wanted to know. Do you have any softball players in? So you probably already knew that number. So now you know. And if you forget, you could always figure it out. I mean, would you know that was 45 degrees? All right, look at the next one, read it. Okay, so what do we know of the triangle?
Do we know of it? We
Yeah.
have all the sides.
All the sides
No angles.
and no angles. What do you think we need to find?
Angles.
We need to find all the angles.
2 of them, or one of them, is all sides. Either way.
Actually, what we're trying to find is we're trying to
Oh, no,
find
this
the
puts
bearing.
bearing.
The bearing from B to C. So we're trying to find the bearing, and bearing always goes off of north or south. So I'm going to draw a north-south at B. Here is east-west already drawn for us. So this bearing is going to start with either north or south. Which one? It's going to start with north. Then it's going to have some degree, which is going to be right here. And then it's going to have what direction after that? East. All right, so we're trying to find north, something, east. We just have to find that degree. So I really don't need to find angle A or angle C. I only need to find angle B. So let's start there. Let's find angle B. You use the alternative form. It's going to start with cosine B. And then we will be adding the squares of the other two sides that are not B. It's the two that are next to B. 60 and 80 squared. And we subtract off we subtract off what B is squared. And this is just from the formula, dividing by 2 times the two sides that are not B. And then to type that in our calculator, inverse cosine. Mm-hmm.
They put the fraction to make the exponent spot. It's not what I want.
You're having calculator struggles.
Yeah, I gotta keep remembering to hit.
Well, you could do it by hand.
Up to the fast.
I mean, what did students do before these graphing calculators?
They didn't.
I don't know. I don't
There
know.
is a chart that.
Yeah, I remember.
Do you remember seeing the chart, the
Yes.
trigonometry chart that says what the sine of 139 or cosine of the 139 or whatever? I wouldn't say
Probably
that,
took forever. to
like, has
figure out what
everything.
it's-
uh-huh.
Yeah, I did have.
But that's why somebody was like, I'm done with doing this by hand. I'm going to create a calculator that does it for me. That's what happened. They were motivated. We have a little bit less motivation today because everything's made so easy. Okay, so this is not the answer. This is not the answer. From what?
We have to do one for one.
We're trying to find this.
Oh, wait, so that's in between, so that's our whole angle,
That's-
So now.
Yeah, 166 is the whole angle. What is this over here?
A right angle.
So subtract 90 from your last answer. Just hit minus 90 on your calculator. And we should have our final bearing
676.
north, 76.15 I think it is, right?
Yeah.
And then east.
Okay.
Okay, one last example, and it is called Heron's formula, and it is the formula for the area of a triangle. But this would be the formula for the area of a triangle when we know all three sides. We don't know any angles, we know all three sides. To do this, you have to first find an S value. An S value, you add up all the sides and divide by 2. After you find S, then you just use that S and you plug it in, and you use all three sides A, B, and C, and you plug them in, and square root the answer, that's it. So we're just going to use this formula to find the area of a triangle. First find S. S is all three sides added up, divided by 2. All three sides added up, divided by 2. Then we do the square root of the S value. And you multiply that by S minus A, so 84 minus 43, multiplied by 84 minus 53, multiplied by 84 minus 72. Type it in your calculator. There's even no need to take 84 minus 43 by hand. There's no need, unless you want to practice your math steps. Nothing wrong with that. Or you just type in the whole thing in the calculator. So you got a negative sign underneath. So.
Oh, no. I think I mixed up my parentheses.
Did you do the A, B, and C first?
No, I just put the parentheses in a weird spot.
Oh, okay.
So it was like so redundant, my brain just kind of shut down.
You can do it by hand.
Good.
All right, so your assignment is in the book.
There we
It's
go.
all odds. So those odds are there for you to check your answer and figure out what you did wrong there, not there, so that you can write down the correct answer.
Oh, that's
1131. Okay. Meters squared. All right, I'll go back. Let me just stop the video.